Okay, let's go back up in our notes and look at our endpoints from the sphere. Okay, I believe there were 0 and R, 0 and, oh yeah. So when I was doing this integral, where was it? Yeah, right here, you can see it. Okay, here's my region. Here's my region here that I'm rotating about the x-axis. And as I move through that region, the x values go from x is 0 to x is r. Okay, for that reason, I end up with this integral, oh dear, from 0 to r. Okay, next one, same idea. Here we go. Where was I? Now, if you look at the region, let's go yellow. If you look at the region here, my banana goes from x is 0 to x is 1. Okay, for that reason, I get 0 and 1 here as my bounds of integration. Okay, where are we now? We had 19 pi over 12. Okay, exercise. Pause, copy, try, pause, copy, try. Here's your answer, 4 pi over 3. Oops, forgot to give you the x-axis. Pause, copy, try, pause, copy, try. Sorry. Pause, copy, try. Okay, an example where we're rotating about a different axis, the y-axis now. 3 curves. My region R is bounded by 3 curves. Let's have a look. This equation is a bit familiar. You can square both sides to get 4y, and then y is a quarter x squared. That's a slightly more familiar formula, if you prefer. But just want to get an idea of what it looks like. Here's my region R. Now I'm rotating now about the y-axis. Okay, so I'm going to get some kind of bowl-shaped thing. Oh, that's not good. And what do I do? Well, let's copy this picture now with a representative rectangle drawn in. So pause and copy. And this time I'm not getting washers. I'm getting discs. Because the inner radius is 0. So the inner radius is 0, so I'm just going to get disk. So there's no circle to be cut out of the interior here. Now look what I've done here. I've drawn a delta y here. That's important. So I use a different letter, okay, because that's a vertical, this right here. This is a vertical chunk of distance. So I should put delta y. What does that tell me? It tells me that ultimately my integral is going to be something dy. So what does that tell me? It tells me that all of this, I should have a function of y here. Okay, something just depending on y. I don't want any x's. No x's in here. Because that's a delta y. So I take this point here, and I make sure to write it only in terms of y. Okay, so my x value is replaced with 2 root y. Okay, now I'm ready to set up my integral. Okay, now it's an integral with respect to y. So I'm going from y equals 0 to y equals 9. So I'm going to have a 0 and a 9 here. Let's see. Okay, same idea as before. Outer radius, inner radius. In this case, the inner radius is 0. And the outer radius is exactly the x value of this point here. So not much else to say. You work it out, and you are done. Okay, exercise. Pause, copy, try. Pause, copy, try. Okay. Now I'll do an example with a different flavor. Now we're rotating not about the x-axis, not about the y-axis, but about the vertical line. X is equal to 2. Here's my region, bounded by 3 curves this time. And there's the picture I get. Volcano-looking thing. So what do you think? Do you agree with the volcano? Is that what you see when you take this triangular-looking region and rotate it about this axis? I hope so. So pause and copy that if you haven't done so already. Now, let's see what I want here. Okay. So pause and copy this diagram here. Lots of diagrams here in this chapter. Lots of pictures. Now, let's talk about a couple things. First thing I want to talk about is why I chose to draw my rectangle horizontally and not vertically. You say, oh, why don't I just go like that? Draw a vertical rectangle like this. Why did I not do this thing in green? Well, if you imagine this green thing rotated about x equals 2, okay, what you get is called a cylindrical shell. Now, there's nothing wrong with that, but that's what we would do in 6.3. But not in 6.2. So 6.2, we're going to want to have, when we rotate a rectangle, we want it to be a disc or a washer. Okay, no cylindrical shells. Okay, so with this rectangle as I've drawn here, once again, I got a delta y here, so I should take my point and eliminate all the x's before I proceed. Inner radius is fixed. Okay, it doesn't change. It's always just 1. The outer radius is the tricky bit. Let me get a nice bright color, orange. Now, what is the outer radius? Now, I would think of it as being, you start with 2. This is 2. And then you're going to subtract this bit here. Okay, so R0 is 2 minus the x value of this point here. Again, here I've drawn a fixed length 2, and the length I want is that 2, subtract the x value of this point here. That's why I get this expression down here. That is typically the hardest thing in 6.2, is just getting the correct form for the outer radius and the inner radius. Okay, the rest of it, as you'll see, is sometimes a laborious integral, but not technically difficult. So I grind this out, so let's just pause and copy from here. Nothing much to say. about that.